Phew, that last one was a long one. Let's get to part 3 here of Pythagorean theorem. It's called the converse, but it's basically just another use for the Pythagorean theorem. It allows us to tell if a triangle, first of all, 3 sides can make a triangle, and second, what kind of triangle it's going to be. So we've got 3 different options for that. So if we do have a triangle, and I'll talk about that here in just a second, then I know if I have this equation where c squared is going to equal a squared plus b squared. So you can see basically what I've done is I've switched the equation around. If this value of c, which is the longest side, equals the sum of the squares of the other two, if it's equal, then it's going to be a right triangle. C is always going to be the longest. Now, if I take 3 sides, or 3 lengths, and c squared happens to be greater than the sum of the squares of the other two, that's going to be obtuse triangle. And I think you can see if c squared is less than the sum of the squares, then that's going to be an acute triangle. Now, it's pretty easy to remember. Obviously, the Pythagorean theorem, if it's equal, it's going to be right. If it's greater than, it's going to be bigger than a right angle. So it's going to be bigger, which means obtuse angle. If it's less than a right angle, it's going to be acute. Always keep the c squared on the left side. Kind of keep it in this order, because then that fact I just told you about greater than and less than remains true for obtuse and acute. Now, I don't think we've done this before where it says, recall from earlier. So basically what it means is if I gave you 3 sticks and I could make a triangle out of them, or could I? All right, so based on the fact that when I have triangle that has the lengths of 3, 7, and 9, in order for this to be a triangle, if I had 3 inches, 7 inches, and 9 inches of sticks, could I make a triangle out of them where it goes from point to point? Basically, all you have to do is take the 2 smallest sides and add them together, and they have to be greater than the 3rd side. So in this case, I could take 3 plus 7, which is greater than 9, so then yes, it is a triangle. Okay, so if it is a triangle, then I'm going to decide what kind is it. So I'm going to take the c, which is the longest, which in this case is 9, and I'm going to check to see if I take the other 2 and square them. This one's going to be 81. This one's going to be 9 plus 49. So 81 and 58. 81 is greater than 58. So that means this triangle of 3, 7, and 9 is going to be obtuse. So first thing we're going to do is we're going to check to see is it a triangle or not. So we take the 2 shorter ones. Okay, so that's 41, and that is greater than 29. So yes, it is a triangle. You take the longest side over here, and then you check what your totals are going to be. Okay, so 29 is going to give me 841. This is going to be 841 also. So if those 2 are equal to each other, if I take this and square it and add them together, I get 841. When they are equal to each other, then it is a right triangle. Take the 2 shortest, 4 plus 11, and that is less than 16, so this is not even a triangle. I think you can see 17 plus 17 is 34, so it's a triangle. So I take the longest side, and I'm going to check 17 squared plus 17 squared. And when I do so, this is 484. This is going to be 289 plus 289, 484, and 578. This one when I add these two together. So it would read 484 is less than 578. So that means it is an acute triangle. Okay, you do the last four, and then we'll come back and I'll show you the notes for it. So here are the notes for the last four. You can see number 5. Again, you're going to take the C, which is going to be the longest side. It's going to go over here on the left. This one happens to be equal, so it's a right triangle. When I take the two shortest sides here, they are not greater than the third side, so this is not even a triangle. And you can see 7 and 8, what you do on each of those. The process is the same no matter what. So if you have any questions, let me know. That's all for 1C.